All right, let's dive into one of the most strategic and frankly brilliant moves happening in the AI hardware race right now. We're going to break down Nvidia's massive bet on the future of the data center.
So, Nvidia recently spent nearly $1 billion. But what they bought might surprise you. It wasn't some flashy startup you've heard of. Nope. It was something way more fundamental to where AI is going next.
You see, this wasn't a typical acquisition. It was what's called a strategic acqui-hire of a startup named Enfabrica. Nvidia brought their core team in-house and licensed their key tech, all to solve this huge, invisible problem that's been holding back AI's true potential.
Okay, to really get why this $900 million bet is so critical, we have to look under the hood. We need to talk about the massive data traffic jam happening inside every single AI data center at this very moment. It's a bottleneck that could seriously stall the incredible growth we're seeing in AI.
For decades, data centers were built with this siloed approach. You had your compute over here, your storage over there, and your networking as its own separate thing. They were all independent layers. But for the giant, interconnected jobs that modern AI demands, this old way just doesn't cut it anymore.
This old design creates a huge problem, something folks in the industry call protocol islands. Just think about it like this. Your GPUs are speaking one language, NVLink. Then they have to talk to the CPUs in another language, PCIe. And to talk to other server racks, that's a third language, Ethernet. Every single time data has to cross one of these boundaries, it needs to be translated. And that translation creates delays and kills performance at scale.
And this crippling traffic jam? It actually has a name, the I/O wall. It is the #1 physical barrier that stops thousands of GPSes from working together as one big, efficient brain. And that's exactly what you need to train and run these new massive AI models.
So that's the problem. And this is where Enfabrica's solution is just so elegant. Their idea is radical. Stop building all these separate, slow little backroads. Instead, let's build a single, unified data superhighway for everything.
They call this an accelerated compute fabric, or ACF. And really, you can think of it as a universal translator and a high-speed transit system all rolled into one. It creates a physical layer where all those different languages, storage, networking, compute, can travel together seamlessly, which means you don't need those slow, painful translations anymore. The ultimate mission here is, and I just love this phrasing, to effectively smelt thousands of individual servers, with all their walled-off components, and reforge them into one colossal rack-scale machine where everything can talk to everything else instantly.
So how in the world do they do all this? Well, the magic behind this entire concept really comes down to a single, revolutionary piece of silicon. It's a chip that completely changes the game for what a network interface card, or a NIC, can even be.
This is Enfabrica's flagship product, the ACS chip, codenamed Millennium. And people are calling it a superNIC because it brilliantly crams 3 separate critical hardware jobs into one device. It's a high-speed network card, a PCI switch for all that component-to-component talk, and a CXL memory manager. And this table just lays out the massive leap in performance. I mean, just look at the total throughput. We're going from maybe 800 gigabits per second in a traditional setup to 3.2 terabits per second with a single chip. But what might be even more important is the network latency. By creating this flatter, more direct network, the number of hops or data transfer delays gets cut from as many as 5 all the way down to just 2. Yeah, that's a potential 8-fold increase in data throughput from just one chip. It completely smashes through that I/O wall we were talking about by getting rid of those protocol bottlenecks.
So what's the grand vision here? What does all this incredible technology actually enable? Well, it's nothing less than a fundamental shift in what we even call a computer. This is Nvidia's goal. This is the endgame. They want to stop selling you individual servers. Instead, they want to sell you an entire rack as one single, cohesive, monstrously powerful computer. The basic unit of computing is no longer the server, it's the rack.
And this whole vision is unlocked by a key concept called memory disaggregation. So instead of memory being trapped inside one specific server, it's pulled out and put into this giant shared pool. This means any GPU in the whole rack can access that memory directly, which gets rid of so much waste and lets you put resources exactly where they're needed, when they're needed.
And the economic impact of this, it's just staggering. By using memory and GPUs way more efficiently, This new architecture can slash the cost of running large language models. The analysis suggests that for inference tasks, you could cut the cost per token by up to 50%. That is a total game changer for making AI profit.
So when you put all these pieces together, this $900 million move, it really just reveals Nvidia's ultimate strategy for dominating the next decade of AI infrastructure.
What this really shows is that Nvidia is moving way beyond the chip business. They are now in the business of designing the fundamental blueprint of the AI data center itself. They're not just selling the bricks anymore. They're selling the design for the entire factory.
By grabbing Enfabrica's technology, Nvidia gains control over the most critical choke points in the data center. They get to define the unified fabric, they set the physical rules for how data moves, and it reinforces their whole strategy of selling a complete, optimized closed-loop system where the rack is the computer. And all of this leaves us with one last, pretty provocative thought. If Enfabrica's tech really does help Nvidia redefine a computer as an entire rack of equipment, well, that forces us to ask a much, much bigger question. What on earth does the data center of tomorrow even look like?